Today, I'm breaking down the big three: HTML, CSS, and JavaScript. For a decade, if I wanted to know how to safely vent a boiler, I would go to the IFGC. Or when I went to wire a high voltage panel, I went to the NEC. Those books are the source of truth, the logic that keeps a building from burning down. But now, I'm learning a different kind of code. People ask me, Sheldon, what is software engineering? It sounds complicated, but to a guy like me, it's just a digital code book. It's a set of instructions that tells a computer exactly how to behave. In the trades, we respect the code because it's the difference between a system that works and a system that fails. Software is no different, using the same logic we used in the trades to build something that lasts. If you've ever looked at a set of blueprints or a wiring diagram, you already understand more about programming than you think. Think of HTML as your mechanical code. It's the skeleton. You don't just throw a furnace into a bedroom. You need an HVAC plan to find the best spot to put the furnace and to run the ductwork. HTML stands for Hypertext Markup Language, but I call it systematic structure. Think of HTML as your mechanical code. It is the skeleton. You don't just throw a furnace into a bedroom. You need an HVAC plan to find the best spot to put the furnace and to run the ductwork. It tells the browser exactly what each piece of content is. In the field, you wouldn't just tie a high-efficiency furnace into a plumbing vent for a furnace exhaust. That won't work. In code, using tags like header, main, or footer is just like following a blueprint to ensure the supply lines and return lines are in the right place, as well as the furnace. If you just use a bunch of generic div tags, it's like building a house with nothing but 2x4s, and no headers and no footers. It may stand up for a minute, but a professional or a search engine is going to look and just know it's a hack job. Without good HTML, your website is just like a pile of lumber just sitting on the ground, or a whole bunch of ductwork just sitting there. It's not about how it looks yet. It's about making sure the structure is solid so the rest of the system can actually plug into it. You build the frame before you ever think about the paint. Once the framing is up or the ductwork is hung, you don't leave it exposed. You add the finishing touches. That's where CSS comes in, cascading style sheets. If HTML is the framing or the trunk and return lines for ductwork, CSS is the finish work. It's the layout, the colors, and the spacing. In the trades, we take pride in clean installs. We make sure every pipe is level, every duct is sealed, and every wire is tucked away and labeled. That's what CSS does for the web. When I'm using Flexbox to align elements or setting up CSS variables to keep my colors consistent, I'm doing the digital version of a clean mechanical room or a clean panel. I've seen some panels that are just a cat's nest, and I've seen other panels that are very beautifully labeled, and every wire is made to look perfect. It's the aesthetic that makes a user trust your work. Think about it. If you walk into a mechanical room and see pipes crossing everywhere and wires hanging out of boxes, or the panel looks like a rat's nest, you don't trust the contractor, even if it works. CSS is where we apply the precision that proves we know what we're doing. It makes the website look clean and crisp. But if the alignment is off or the buttons are hard to find, the user loses confidence. Finally, we have JavaScript. In the trades, we call this the sequence of operation. You can have a beautiful boiler system and a solid frame, but if the control board doesn't tell the inducer motor to start, the house stays cold. JavaScript is the brain. It's the logic. It handles the events. It tells if the user clicks this button, then run this calculation and display the result. It is exactly like troubleshooting a control circuit. When I'm writing a JavaScript function, I'm just building a digital relay system. In my avatar trivia app, for example, The JavaScript is consistently listening. It's waiting for a trigger. A user chooses, and then it executes a specific set of instructions to update the score or to move to the next question. It is the part of software engineering that makes the project come alive. Without logic, your website is just a static picture. With JavaScript, it becomes a tool that actually solves a problem for the person using it. So this is why I'm moving so fast through Coding Temple. I'm not learning these things from scratch. I'm just translating my years of systems thinking into a new language. I've spent my life looking how parts interact within a larger machine. The reason I went with a bootcamp over being entirely self-taught, it's simple. I wanted to master a code book. Self-teaching is like trying to learn the NEC by reading random forum posts. You might get the answer eventually, but it's slow, and you might miss a critical safety detail. At the bootcamp, the instructors point me in the right direction and give me the documentation I need to work smarter. They provide the guardrails. Instead of wandering around YouTube and trying to figure out what I don't know, I can focus 100% of my energy on the logic. It's about bypassing the fluff and getting straight to the core skills that get systems built and get people hired. Software engineering isn't magic, it's infrastructure. Whether you're moving air through a building or moving data through a server, it's all about building systems that solve problems. I'm Sheldon Young, and I'm trading my tin snips and pipe wrenches for keyboard commands. But the mission is the same. Build it right, follow the code. It's an adventure. Subscribe to see how these 3 languages are helping me rebuild my life from the ground up. And if you're a tradesman thinking about making a jump like this, stay tuned. I'm proving it can be done. And I'll see you in the next one.